Slack channel in our NetDev Slack called NetDevOps Days. So plenty of ways to keep up to date with us. Thank you for all your support on the first one, and we're hoping to make this one bigger and better. That's all from me.
Awesome. Thank you, Mark. I'm when the London one was announced, I knew I was going to have a little bit of FOMO that I wasn't going to be able to make it out to it. So I'm really excited to have one here stateside. So hopefully you'll be there for it. But looking forward to it. So thank you for that. Next up, just have a couple small things. Just wanted to give everyone an update on NetBox 3.6. So that is on target for a beta a little bit later this month, with the full release of that coming shortly after. Might be into September, but that's loosely what we're looking at. Then that's going to get us lined up for 4.0, which we should be seeing towards the end of the year. There's going to be some fun changes in 4.0. I know we're going to get into some localization efforts within 4.0. So being able to bring NetBox in more languages with the easy translate built in. There'll be some work behind that, that we'll need to get those translations done. But as far as the roadmap goes, you can check the GitHub for that, and you can see what's currently being worked on, what's coming next, and all those goodies. Then the last thing that I'll mention is the plugin board that's out there for crowdsourcing plugin ideas. That lends itself a little bit into the plugin bounty that we talked about last month as well. We'll make sure that we get some links out for those. You can also take a look at last month's call if you'd like a little bit more information on those. But those are still out there, and look forward to people participating in them. All right, time for presentations. So we have Michael Schwartzkopft, Al-Ebrahim, and Ian Chilton, who are going to be doing some presentations for us. I have a brief summary up there, but Michael, as soon as you are ready, go ahead and start your share.
Thank you very much. So I want to talk a little bit today about integration of network with configuration management systems, especially Ansible. And I found the event-driven Ansible, which perfectly fits NetBox webhooks. So the basic architecture is you have a NetBox as source of truth. You have Ansible as a config management system that, pushes out the configs. As an example, I have virtual machines in my data center that I want to manage through NetBox, and you see the question marks. How is NetBox able to trigger some Ansible runs? And I found the Ansible, error there, syntax error, Ansible rule books, Ansible rule books, which basically provide a kind of API, and NetBox can talk to that API. That is very convenient and helps in a lot of ways of working. So basically what you're doing in, so what I'm going to do is I want to generate a new virtual machine in NetBox, and as soon as I trigger the webhook, I want to generate that virtual machine through an Ansible run in my data center or on a cloud provider, to be more specific. So the webhook is virtualization of virtual machine, triggered the webhook. The URL I'm talking to is, well, for the sake of these slides, I have a documentation address here. Port 5000 is where my Ansible rulebook is listening to. And the conditions is the status value is stage or commissioning. So if I have a virtual machine doing an update, and the new status is staged, and it will create the virtual machine. If the new status is decommissioning, it will delete the virtual machine. So that is the webhook inside NetBox. The rule book in Ansible is some kind of this. You have a source, which is the event-driven Ansible webhook. I make it listen to port 5000, and then you have the rules. If this happens, Ansible rulebook should do that. The condition is the event payload is a virtual machine, and the virtual machine data gets updated, and the new status is staged. For decommission, you can imagine the rest, and the action, the condition of the rule, and the action of the rule is run a playbook, and I have a playbook create droplet because I'm using DigitalOcean as a cloud provider, and they call their virtual machines droplets. So I create droplets, and I set the virtual machine variable to the payload of the event, which is the virtual machine data about the virtual machine. And this virtual machine data is passed to my playbook, and the playbook is looking like that. I have a DigitalOcean droplet, which I ensure that it's present. And here's the name of the virtual machine. You see the variable virtual machine.name. I have the size, I have the region, all variables originating in NetBox. I use the platform slug as the image. It takes its time to generate machine in DigitalOcean. When I tried it today, it takes about 10 minutes to create it. So we'll see whether we can do it during this presentation or not. We'll start there anyway. And finally, I register the data about the new machine in a variable new droplet and pass this information back to NetBox. I didn't show all the rest of the playbook because it's quite long. We can have a short look into the playbook afterwards. Now for the presentation, it is, well, let's go first to my NetBox. I have a virtual machine. I have a template here, and I have a NetBox with a template. I clone the template. I call the new virtual machine VM01. Status is planned. The cluster is Frankfurt 1 because I want to have it in Frankfurt. The platform is Debian 11. You see the resources, vCPUs, memory, and disk, which fits to the data of the droplets in DigitalOcean. So I created the status. At the moment is planned. Everything looks fine. And now I go to my Ansible machine and start the rule book, which basically opens port 5000 for listening. We have to wait a little bit. Now it's listening. And now we can edit this machine, set its status to staged, and save the new status. And now we see that it's running. Gathering effects. Well, it's here. The debug output is the data of the virtual machine. Here you see Debian 11, the CPUs, the disk, the memory. There is no IP address in this virtual machine defined because when I create a droplet, then DigitalOcean assigns a new IP address, and the rest of my Ansible playbook is when it's created the machine, it will store these data back to NetBox, assign the IP address to that machine, and finally set the status to active. I tried it. Creating the droplet takes about 10 minutes, so I think I will run out of time. We can let it run during Ali Guts' presentation, and we'll see. We might have a quick look into how it looks finally. So basically, this is the machine. At the moment, it's staged, and we're waiting for DigitalOcean to create the virtual machine. Within 10 minutes, I get the IP address, and I can log into that new machine. And so we have here. So we have the whole chain. NetBox triggers. If an event happens in NetBox, it triggers the webhook. It talks to the rule book in Ansible, and Ansible finally does something. I think it's a very elegant way to connect NetBox to the real world and to do things from NetBox through Ansible config management and really do something. For instance, creating virtual machines. So it's still running. Oh yeah, here. Here is my DigitalOcean. Oh. Yeah, not yet created the virtual machine. It takes its time. So yeah, let's wait for the machine to be created. In the meantime, I will write a blog about article about all the stuff here and the playbooks and the runbooks I use. It will be published on our website, sys4.de, and there we have the blog. I have, yeah, from time to time I write something about NetBox mostly. Yeah, there will be this new rule books connection with NetBox I will publish also here. So yeah, that is the integration. Thank you very much for your attention. Open for discussion.
Yeah, quick question for you. So you're tying that webhook in there. Maybe if we get a little bit later on into the open Q&A, could you show off that webhook, how you have that structured and put together?
Yeah, I think we have 2 minutes of time. So yeah. The webhook is very, very simple. Here is the webhook. Manage VM. It's enabled. The event is an update of the virtual machine because I create the virtual machine in the state planned. And when I update it, like setting it to staged, then the condition is the status is in decommissioning or staged. The assigned model is a virtual machine. And finally, I'm just calling my event-driven Ansible with this payload URL, and I don't have any specific body. I just take the body, which is a data of the virtual machine, pass it on to Ansible, and this is a debug output of the data of the virtual machine. As you can see here, it's 512. It's a name. Yeah, it's created in Frankfurt data center, and yeah, that's it.
That's really cool. The reason I asked you to bring that up to show specifically is that sometimes I feel like webhooks, they're very powerful, but when people are still kind of figuring out network automation, what the journey looks like, just the different ways that they can use NetBox to not just collect information, but actually put it in action. That's really the reason I wanted you to flip back to it, is just to give anyone who's watching just a little bit of a sample of what's a simple webhook can look like, but really how powerful it can be on the back end. So that's terrific. Thanks for that.
Yeah, so you can decide to make the body of the webhook look like you need it, or you do it inside Ansible. Yeah, so it's either doing the work here or there. I decide to do the work inside Ansible, so deriving everything from the VM data. So it's simple.
Yeah, that's nice. I'm really looking forward to the blog write-up. And just personally aside, I really like the format of your blog. Just wanted to put that out there.
Thanks.
Awesome. Thank you, Michael.
To the developers.
Yeah, let them know. Pass along those words. So if anyone has any other questions for Michael, we'll have some more time at the end. But next, we're going to go ahead and hand off to Ali. And you're doing something with AI. I've heard about AI, but I'm really not familiar with it. So help me understand. That's a joke. Just putting that out there.
Oh yeah, the last 6 months we haven't heard enough about AI, that's for sure.
Right.
No, the AI I'm about to show you is a completely different type. It's actually an alternative to deep learning. So it can be applied at the edge or applied to very little data sets, like the list of devices we'd have in a NetBox account. And I'm keen to show it to you. Thank you so much for the handoff, Jordan. Should I just start?
Yeah, go ahead. All you.
Great. I have my teammate Shane here with me as well. We're from AO Labs. We're a research venture based out of Berkeley. And like I said, we're working on an alternative to deep learning. So full disclaimer, I didn't know much about device discovery. I only really learned about it because one of our users was an engineer at NetBox who thought of applying our AI to device discovery. So we put together this app that I'm really keen to show you. And I'm also keen to get your feedback to see if it can apply more in any of the NetBox instances you have, or maybe ways of extending it to fit other things, not just device discovery. So I'm going to share my screen and just go ahead and show you what we got. And I don't mind interactive questions if you guys want to jump in. I'm really liking this community meetup here. So anytime you have any questions, please feel free to jump in. Let me share my screen. Oops. So we're all familiar with NetBox, the lovely homepage that we can customize. The part that I'm specifically looking at, like the presentation previously was about virtualization. Here I'm talking about device discovery. So I'm logged in here to demo.netbox.dev. And at this moment, there's 77 devices on this network, everything from Tor switches to routers to patch panels. Now, this list of devices is constantly changing as I've learned interacting with this demo instance myself. And it's also dependent on, I assume that each NetBox instance kind of has it set up in a different way, what information they care about here. When adding new devices, and this is what I know of device discovery, when adding of new devices, it's really a pain in the ass, quite frankly, sometimes, where you have to kind of do this all manually. Like here, if I was to add this device and I was to commit maybe a cardinal sin of putting a Tor switch as something like that, just very sloppily adding a device, I can do it, but there's really no validation. And also, even if I was to add a device in bulk, it's still an issue of like there's manually a human validating. So the conversation we had with the person who was at NetBox was, can we have an AI automate this? Can we have an AI agent unique to each NetBox account to automate this for that account? So that's the demo I can show here. We have this page. You can try it out at bit.ly/netboxdd. You can try it out if you have a NetBox cloud account. So here I can connect this device discovery demo that I'm about to show you. The agent is running in the background. I can connect it to demo.netbox.dev. Let me grab my API token real quick.
Can you drop that bit.ly link, or maybe your coworker can drop that bit.ly link in chat for us?
Let me do that right now.
Sure.
I just generated it before the call, so
Yeah, just click create.
yeah, sorry, just let me share the bit.ly link. There you go. So now I can connect the AI agent that's running in the background of this app to that instance. So there's 78 devices in that instance, as we saw. I'm going to use all 78 for this demo. From those 78 devices, I'm going to go ahead and hide 28 devices, imagining that those are going to be newly discovered devices that we're going to test the agent on. But of course, if this agent was running, it can live in parallel with your list of devices, really. So this is just a snapshot. Let me call it 78, 28. And now you have an option of spinning up the agent, locally. They're really meant to be run locally. But we also have an agent as a service API set up. I'm going to go ahead and spin up this agent locally for now. So it's actually running in the browser session. So there we connected it to the NetBox account. Let me confirm that it's connected. Now we can imagine what it would be like to use this agent for device discovery. So you might be in a situation where you have to add all of these new devices, right? You have their names. You have to add these 28 new devices. We know the manufacturers. We might know the site and the type. Can we help you out? Can this AI agent help you out by predicting what role those devices are likely to have in your NetBox instance, given your previous setup of devices? We have here the actual role of those devices, those 28 devices that we pulled out, so we can compare results. So this agent, again, is only trained on 50 devices from that list of NetBox devices. I'm going to run this batch process right now. And there we're told that out of the 28 devices that were added, the role was predicted correctly 19 out of 28 times. So let's take a look. And it's even smart enough to sometimes tell you when it can't make a guess, right? We can filter out improper outputs because it's working with a fixed input output. So this is like no hallucination AI. Let me see if it actually managed to capture the test device I added, the AO Labs test device. No, it didn't. But yeah, so this agent also works as an autocomplete feature. So you'll notice that this agent really made quite a few mistakes. Maybe if the data was more structured, it would have performed better, but it still made quite a few mistakes. Now, part of our philosophy on AI at AO Labs, what we're trying to do to different than deep learning and the stuff we all heard about before, is that this AI is not pre-trained. As you saw, I trained it right now on this list of devices. And in fact, I can continuously live train it. So as an autocomplete, let's imagine the situation as an autocomplete. I might have these list of devices, manufacturer, site, and type again. And now I need to add those new devices. So kind of like parallel to this page over here. And if I'm adding new devices, like let's say this is an APC, oh, there it's giving me a recommendation. And this recommendation, let's say that I do know better. Let's say that I do know that this is actually an access switch, not a Tor switch. So if I do add this new device in this way, the agent is retrained instantly, or continuously trained rather. And so now it'll kind of like expect that to be an access switch going forward. It's not AI if you can't really retrain it yourself, right? You can view the agents you have in session. I can very easily spin up another agent. In fact, I'm going to do that real quick because it's that quick. Let me use less devices. Let me use 50 devices, and we'll use 10 for testing. I'm going to call that 50, 10. And I'm going to spin up this agent on our API. So let's say you decide to play with these agents. Instead of having to host them locally and worry about their persistent memory, we can spin them up in our API. We'll host the agents for you. But super happy to have the agents live in your code as well, depending on your needs. It's a bit slower on the API. I have it throttled right now. But there you go. I might be in a similar situation. These are my list of devices. Let's see how this agent performs. This is agent 5010. There. In this case, actually, it performed very well. Very cool. Didn't expect that. And again, as an autocomplete, I can like actually I can go mess up its training right now. Let's say that again, I'm a sloppy NetBox user, and I have this Tor switch that I'm forcing it to be an access switch. And I'm going to do that. Just yeah. Let's see how that affects it now. If I was to run this again, it might get slightly worse results. In this case, I mistrained it, but well, no, it's still good. And there you can view both agents. This one is hosted on the API. This one's a local agent living in the browser session. These agents are well documented, so you can go ahead and spin up as many as you need. You can even configure it, because right now this agent here was specifically taking in the manufacturer type, site, and role, and correlating, sorry, the manufacturer type and site, and correlating that with role, learning to associate that with role. You can very easily configure an agent for any other part of NetBox. But I'll pause here for questions, because again, I'm really learning about device discovery, and I would love to see if these agents are useful and helpful. I'll pause here for a few questions before Jordan cuts it off for more questions at the end.
Yeah, I know I have a ton of questions, but I'll save for the end. So we've got about 2 minutes left. Can do a little bit more if we're going over. But any questions for Ali?
Cool. If there aren't any questions, I can just show, like in the last 2 minutes, I can just show a few more resources here. You can look at how this agent is coded up. All of this is open source and available. So the agent, this particular application, looking at it, that's the main page here. We're using Streamlit for the front end. We're really AI people. We don't know anything other than AI. So we're using Streamlit for the front end. But this is where I just want to show one thing here real quick. This is where that agent is configured. It's literally only taking in manufacturer, type, and site for role. And we have 10 parameters to capture the manufacturer ID and turn it into our agent's binary. Thank you. I'll pause for now. Thank you all for that.
Yeah. So there's a quick question there in chat asking about trying it using Docker. Is that a possibility?
Yes. Yes. So you just need to spin up a Python environment in a Docker container, and then you can run the agent in that Docker container for sure. Yeah.
Cool.
The agent is an object.
And just so you're aware, your Discord link isn't working. I instantly tried to join, and it's
Oh, thank you for that.
Yeah.
I'll make sure to post the proper one here. Thank you.
That's what you bet. Wow, that's impressive. I like I said, I have questions, but we'll go ahead and save those for the end.
Yeah, please. We need use cases. Maybe we can, like, we literally spun this up. You can easily configure the agent to take in any other type of information. So for devices, maybe there's other applications that are more even pertinent. So thank you.
Absolutely.
Let me stop sharing now.
All right. Our last presenter for the day, Ian. Let's see here. I know I have a note here. I won't give it away, but Ian Chilton, I'll go ahead and let you step on and start your share.
Hey, good afternoon, or evening, depending where you are in the world. Can everyone hear me okay? Is that coming through okay?
Loud and clear.
Yep, great. Okay, well, I'm Ian Chilton from LonApp. We're an internet exchange point in the UK. I recently did an episode of the NetBox Heroes podcast. So if you kind of want more information about me or LonApp, or I use a NetBox or anything like that, then do check that out. I also recently gave a presentation at Net DevOps Days London, the event Mark mentioned earlier. This is kind of a very cut down snippet of that. So again, if you're kind of interested in things I talk about here, I believe the videos of that conference will be released shortly. So do check those out. Very quick introduction to LonApp. We're a not-for-profit neutral internet exchange point. We have about 8 points of presence across 7 of the major London data centers. We have approximately 250 members, 350 connected ports. We peak at a terabit per second of traffic, and we do all that with 4 full-time staff. These are our points of presence. So we run a leaf spine topology, light and dark fiber between all of these sites. So diving straight into network automation, a couple of years ago, I set up this kind of structure. So we had SaltStack, which handled our automation. That used Napalm to talk to switches. Then we took data from a variety of sources. We took templates that were in Ginger, config from GitLab repos, obviously NetBox. We use NetBox a lot for our inventory management, for our VLAN and IP address management. We have plans to use it for a lot more in the future. And then we take a lot of data from IXP Manager, which is all of our members and ports they have with us. That's kind of like our CRM and also our portal for members to get graphs and information and all that kind of thing. This worked well for a couple of years, but I wasn't really using much of SaltStack, if you like. A lot of the logic was built into the templates. You know, we were basically just using SaltStack to parse those templates and inject some data. So more recently, what I started doing is replacing SaltStack with our own code, which kind of talk about here. So that brings it all within our control instead of relying on a big open source project like SaltStack. It then has minimal dependencies. It can be faster because it hasn't got that overhead of, you know, a big project like SaltStack. It can be more flexible, and we can design the interface and the scope of the tooling exactly how we want it to. So I just kind of wanted to give it's not a live demo, but just a kind of glimpse of how that works. So basically we can call it with some parameters. We want to target certain switches, and then we've got like an action and parameter kind of system. So then we can use that to target different devices. So there's a action called targets, which will show me what devices would be targeted if I ran it. You know, so we can target single device, multiple devices. We can put wildcards in there. We can say, oh, we only want to do edge boxes and ignore the spines. We can exclude boxes. We can even exclude with wildcards as well. Then what we can also do is target all boxes. And if we target more than one host, it then uses threads to run all this concurrently. So we're not waiting for each box to come back. It does it all concurrently. And then I'll just give an example of some of the things, you know, we can, not very interesting, but we can pull facts from the various devices. So for instance, you know, across a load of devices, what versions are they running, you know, what models are the switches, etc. We can, this isn't something we'd normally do, because normally we would parse templates to apply configuration, but we could this is just a kind of example of the flow, if you like. We can manually say set a certain config on a box. That then, like I say, goes off concurrently. And I've targeted 4 boxes there. That's gone off concurrently to those boxes, and it's come back and said 2 already have that config, so there are no changes. One of them actually errored, so it handles that and displays the error, and then the other one didn't have that code, so I've got a very uninteresting diff there. It's only 1 line, but it's basically saying I'm going to add that. Then it prompts us and says, do we want to commit those changes? So we can say yes. And then it goes off to just the boxes with changes and makes that change. So that's the kind of the workflow in terms of configuration changes. Like I say, normally we would parse templates and not kind of supply that config on the command line. The other thing I did with this is we use Oxidized for backups. That then pushes to both GitLab, so those backups are backed up, and in real time to our Slack channels. So if anyone else makes changes on the network, we can see that. So what this tool does is it kind of prods Oxidized and says, you know, at the minute we make a config change using this tool, it pokes Oxidized and says, okay, go and recheck the config. That then in turn puts that diff in Slack. So as soon as I run something, my colleagues can then see that I've changed something on the network. This is an example of actually applying config from templates. So this is just a very small config snippet. You'll see it's just Arista EOS config, configuring SFlow, but then we've kind of got these data sources in here as well. So this is just referring to config that I've actually got in a Git repo elsewhere. You know, so the templates are generic, and obviously we could push to different, in this case, we could push to different SFlow hosts, you know, for different targets if we wanted to. And then that's just how that template renders for that device. So for that specific device, we render that template, and that's the config that comes out. Obviously that then can then be applied to the switch. This is again just the way I've kind of created templates is to have them all modular. So we've got stuff that's always common to switches, and then we've got stuff that's stuff that's specific to IXP switches as opposed to management switches or anything else. So I've kind of broken all the templates up so they're really modular, really small, and that therefore makes them really understandable. One thing we can then start doing with these tools is helping us operationally. So one thing we do, obviously we're an internet exchange point. We run a 24/7, 365-day network. If we need to do maintenance that affects member ports, we have to advertise that maintenance in advance. And then what we do is we use something called BGP session culling, where we can in a friendly way cull the traffic from member ports during maintenance. So so now our automation applies that culling. So we can kind of say this device we want to put into maintenance mode. That then through the use of the template snippet I gave you there, then applies that session culling to member ports on that box. Whereas previously we used to go and apply that manually. That's just a bit of a demo of we can render that template, and that's what comes out. And then again, if we run this command, run this tooling for a box in maintenance mode, that's the kind of thing we get. So we get a diff, and then as per that earlier slide, it'll say, do you want to commit that? We can say yes, and it will go off and commit it. The way I developed this tool is to make it really easy to develop and debug these templates. So that was kind of one of the issues with SaltStack was sometimes you get like a funny error, and it can be then very difficult to debug exactly what's going on. This tool lets me pull config from boxes without actually needing to go and log on to those boxes, but it also lets me spit out what data I'm putting into those templates. It lets me spit out the rendered templates. So if anything goes wrong, I can go back and say, okay, this is the template I'm using. This is how it renders. This is the data I'm rendering it with. And, the answer then is generally obvious rather than thinking, what's this error and why on earth is this not working? And then the kind of this part isn't done yet, but the idea behind this tool as well is not just configuration management, but as an operational tool. So things like we want to depref links that might have a problem on them or have gone down. And then we might want to do some day-to-day activities like look up member ports and show us details of them, light levels, status, etc. What's the traffic on certain ports or certain switches? Delve into inventory of optics. So, we need a spare for a particular optic. Where is that on the network? So we can, the idea is to kind of build that kind of thing into this tooling as well. Obviously that then links into NetBox because we have all of our inventory in NetBox, both in terms of devices and hundreds and hundreds of transceivers that we've got across our network. We run scripts that probe the devices. So if we go into the data center, start swapping optics around, taking them to different sites, plugging them in, we then have a script that we can run and update NetBox with exactly where each of those optics, with whatever serial number have appeared on the network. And then just some kind of thoughts or design decisions when I was developing this tool. So obviously, if we're trying to use this tool during maintenance where it's time sensitive, or we're stood in the data center, which is not the easiest environment to stand and start making configuration changes in, it's a nightmare if the tool breaks, but this is a production critical network that's doing a lot of, like I say, up to a terabit per second of internet traffic. So we must not break the network. That's the kind of primary concern. We must generate the correct configuration and apply it to the device. It's better to fail than to generate the wrong configuration, because say one of the data sources is not available, and which breaks the network. Another thing I've tried to do is reduce the dependencies. So if the network breaks, then obviously we don't want the tool to break because it can't reach dependencies, it can't pull data. Think about kind of race conditions when, that screenshot I showed you earlier, where it gives us a diff of the changes and says, do you want to commit them? We just need to think about the race conditions there. What happens if that data changes between me kind of saying, yes, that diff looks okay, and committing it? We want to be sure we're committing the changes that we've seen and approved, not anything that might be more current than that, any changes that might have been made in the meantime. And again, the other approach I've taken is just to cache that external data from things like NetBox and IXP Manager and all of those kind of things. So the tool will work independently of those APIs being functional and being able to reach those systems. Beware of vendor bugs. So just because you have a correct configuration, experience tells me that there might be then a bug applying that. You might have a perfectly correct configuration, which if you type it into a switch will work, but if that's applied in a certain order, or at once in a config session, then you can hit, bugs in vendor software that then say crash your box or whatever. So, just be aware of that kind of thing. And that's all I've got to say.
Awesome. Thanks, Ian. I know that was a condensed version of the longer
that was a
presentation.
whirlwind tour, yeah.
So a good job on that. Does anyone have any questions on that, on anything we saw there?
If I could jump in. If you could, Ian, elaborate on your decision to move away from salt stack to custom code. I'm wondering, when you were making that decision, two-part question, did you evaluate other options before making that jump, like Ansible, Nornir, or Terraform, whatever other orchestration bit before jumping in? And now that you have jumped in and I guess went all custom code, do you feel the effort was worth it? Like that was the right decision? And I ask because I talk about that a lot, making the same decisions.
Ian, before you respond, let me just pause real quick there. Since you did kind of run full there, I just want to wrap everything up, and then we'll just jump into open Q&A, and we'll grab that question first. So awesome, thanks. So thank you for our three presenters for showing up. A really wide variety of topics in here, which is really good to see. It's going to be interesting to see where we go with the AI conversation long term. I have a lot of questions on that as well. So kind of tactically here, Maggie, if you could share the survey link into the chat real quick. If you can, while we're wrapping up and getting into Q&A here, fill that out. Really helps us understand how you found the event this month, I'll say this week. Lets us try and get a good understanding of, are we doing things right? Should we be doing things a little differently? Anything along those lines. 2 minutes, 30 seconds. I was hyping it there, saying 2 minutes, I suppose. If anyone would like to be a presenter in the future, we are always looking for presenters coming on. It doesn't have to be an AI integrated presentation or an Ansible presentation, even if you just have a different way of modeling your network that you want to show off, a report that you came up with, anything that you'd like to brag a little bit about and show off to the NetBox community, we would love to have you on. So there's another link in there for that. Feel free to fill that out. But thank you everyone for attending. Like I said, we'll jump into Q&A now, and we'll start with that first question from Oleg, I believe it is. And Ian, go ahead, kick it off.
Yeah, thanks. So yeah, preface to this is literally in the past couple of weeks. This is kind of hot off the press. This tool, I've kind of started developing it. I've used it to make some production changes, but it's not kind of in general use yet. SaltStack, like I said, has worked well for us for a couple of years. There is kind of the odd annoyance in that it's a little bit slow. And what I mean by that is, it maybe takes 30, 40 seconds to apply the configuration. But if you are kind of doing maintenance, if you stood in the data center, that then feels like a very long time, within context. And like I say, one of the things was I'm using so little of SaltStack because I literally ended up with one action, which is render these templates and apply it to the switch. So it was kind of a unnecessary kind of clobber, if you like. I don't mean that in a negative sense, but in our application, and then you with any kind of big piece of software, you sometimes get breakages. So there was a breakage in one version of SaltStack, which when we updated to, it all stopped working, and I had to kind of roll back versions. So kind of writing our own code just means that it's all within our control. We're reliant on very little, external stuff. Basically this tool and Napalm to apply it to the switch, and then all of the data sources. And like I say, it kind of means we're not bound around a configuration management piece of software. We can kind of write it to do exactly what we want and do other things and do more operational tasks, more like a company tool rather than, this is we're trying to bend around this configuration management thing. Does that kind of answer the question?
Yeah, no, that's exactly perfect. And I asked because struggling with the same kind of decisions around Ansible, where again, using very little Ansible, it's a very big platform. It is kind of slow. And now that we have NetBox for our inventory needs, we use even less of it. So yeah, thank you for sharing your experience. Gives me some encouragement to maybe make the same decision someday.
Yeah, I mean, just to, sorry, you mentioned Ansible. You did ask me about that in the question. Like, have I considered alternatives? I've used Ansible in a different context. And again, I wasn't so keen for this kind of work on that like push model. Where SaltStack worked really well was, it's a central system. Anyone can log into it, make changes, whereas, Ansible is more like, here's the thing, run it against a switch. It's kind of like push, if you like. And yeah, kind of, again, I kind of found it a little bit too slow for how snappy I wanted it to be. I mean, these systems work very well. I'm not knocking them, but kind of, I just had a desire to do something a little differently. And like I say, we're a company of 4 full-time staff, so there's not like big team bureaucracy. We can kind of do these things, and at the end of the day, if it seems to be working well at the moment, in the kind of testing I've done, but if it didn't work out, then we do something different. We can kind of pivot like that.
Thank you. Appreciate that. Appreciate that insight.
Cheers.
Thank you for that. Ali, I have a question for you.
Please.
So in regards to the data set that you're using, that you're building on the fly, more or less, how have you trained that outside of the data that's in the demo right now? Or has it only been, it gets trained each time just against the demo that's in there, right? It's coming in blind each time, right?
It's living in state with the list of devices on the demo. Yes.
Okay. So if somebody, so the
It's not pre-trained on anything else. Yeah.
Okay, and that's where I was going, is the data that's in there can be fairly representative for most environments, and something that we do within NetBox is try and not be overly prescriptive. So even if the roles that are in there work for the majority of people, there's a good chance that may be too many or not enough. So that's something that we would be able to just train it on our own as we continue to add more data into that.
Exactly. That's the point. It's hard to generalize across NetBox instances.
Right.
That's why have an AI agent for each one. They're lightweight enough where you can do that. And it's not pre-trained on anything else. The demo you saw was a snapshot.
Yes.
As code, the API call, the agent can just live in state with your list of devices. It was the agent that you saw was literally only taking in manufacturer type, site, and correlating that with role.
So if at a point
and it
in
was
the
taking
future,
in the IDs, Jordan. It was taking in the IDs too, not the natural language. So it can map to. It was basically just, yeah.
So you were taking the ID of each of those objects and then going fetching what all of those were.
Right. So it would take the manufacturer ID, site ID, type ID, and correlate that with the role ID, and it has that lookup table of all of those. And that's what you can just add to the lookup table to retrain the agent or eliminate anytime, right?
Right. So if at a point in the future, I need to add a new device type, it hasn't seen it at this point in time, brand new, whatever it might be. How many of those types of devices would you say need to be observed in order for it to start getting accurate in matching additional instances down the road?
Well,
how
it's
much
all
data
relative
do we need to
to the
feed
rest of
into
the
it?
data it needs. It's all relative to the rest of the data it has, right? So the agent that we saw right now was trained on the 76 devices that are in the demo instance. The demo instance is refreshed every night, so it has between like 72 at base. Sometimes people add like up to 100 devices or 200 devices on top of it before it's refreshed. But it works with as little as 70, right? You can even try testing it only on a subset of 70, and it works.
Sure.
Answering that in a general sense is hard because it's relative to how structured that data is itself, right? If your data was super structured, like the demo instance sometimes isn't, but if your data is super structured, it works very well, right? We trained this with the NetBox team, with Richard Boucher. We ran this against a few NetBox cloud accounts, between 100 devices to 4,000 devices, and it worked actually better than you saw in the demo instance. So actually, we're keen to see if you can try this against your instances. If your NetBox account is privately hosted, like self-hosted, it's not cloud, there's a script also that you can just run wherever you have Python on your environment to get the agent to do its thing. Essentially, you give it the IDs and it'll give you the ID back out, right, of the role. So we don't even take your, like the natural language, all of that stuff hopefully has some privacy implications as well. But.
Yeah, like I said, that's phenomenal. So we've got about 2 minutes left here, at least for the recording. And then I said, we'll go ahead and power that off and have a more open conversation if anyone would like to stick around. But does anybody else have any questions for right now?
Very quick one. Sorry. Yep. Very quick one for Michael. I might have missed it at the start of the presentation, but obviously the demo you gave called Ansible and created a machine in DigitalOcean. Presumably it can also provision that machine as well. So can you give it some kind of role in NetBox and then it will go and apply configuration to that machine as well as creating it?
Yes, of course. I just showed you a part of the playbook. The rest of my playbook takes the answer from DigitalOcean and feeds it back to NetBox. And of course, you can put in as many tasks as you want to. You can fetch the role and say, okay, good, this is my something else, and go on with roles. That's no problem.
Excellent. Looks really slick. Good.
All right, last call for questions.
I actually have another question on that. I know the webhook there was triggered upon create or modify, sorry, I don't have my video on, of the VM in NetBox. is there support in NetBox to say, like, don't do it immediately, but have like some kind of button to trigger a webhook so that someone can trigger it in the maintenance window as opposed to just middle of the day when it might be a little dangerous?
I don't think this is done in possible in NetBox. I trigger it when the status changes.
Yeah.
So you could write another automation that changes the status during the maintenance windows or something like that.
Yeah.
Or have an Ansible. Well, if you don't want to have it, the webhook trigger an Ansible run, then you could have an Ansible run triggered by cron job.
True, and then just read Ansible. Yeah, of course.
Yeah.
The webhook piece was nice because there it gives kind of users the ability to stay within one UI. So I really like the idea of triggering it without leaving NetBox. That was very attractive about your
in another environment, we use SaltStack, and SaltStack has the API. And so it's very easy to use NetBox to trigger something in SaltStack. But Ansible doesn't have the API. So we have to, when I read about the rule books, it was fantastic. I had to just test it.
Okay, yeah, no, that's great. Yeah, and I guess it shouldn't be too hard to just create some kind of webhook catcher that caches the request and then executes them in a maintenance window later. All right, thank you.
Awesome. So everyone, again, thanks for showing up. We do have the surveys out there and the form to fill out if you would like to be a presenter. So please take a moment to fill out one or both if you're feeling like it. And we will see everybody next month. Take care, everyone. Bye-bye.